Okay, today we're going to start 2.6. 2.6 is a lesson that I do all on its own. I test you all on its own, and it's its own test. Okay, so it is a full test only on 2.6. I've just handed you 9 steps. Okay, after today, every problem I present to you, no matter what the directions say, you are going to complete the 9 steps. Okay, now these 9 steps are not that huge a deal. We just go through the process. It's just the process. Okay? Now, rational functions, remember, are, and what we're going to do, the whole goal of this is to be able to graph rational functions. What you've reduced for the last 2 days, that's step 1 and 2. You reduce, you factored, you reduced, and you found the domain. That is step 1. Says simplify, right? Step 1 is simplify, and step 9 is what?
Find the x-intercept.
No. Step 9 is find the domain. Now, that domain can be done right after you factor, okay? It doesn't have to be at the bottom. It just is right now. So, we've worked on step 1 and step 9 already, and you can't do any other step without step 1. So, a rational function, remember, is just a function that has a function in the numerator and a function in the denominator. What does N stand for? Numerator. What's D stand for? Denominator. Okay? All it is a rational function is just a fraction that has an expression in the numerator or the denominator or both. A rational number has no variables. Now, the domain. Domain is something that I hope you're feeling a little bit better about. Has it gained a little bit from chapter 1?
Yeah.
Our domain? Okay, so, and I promised you every time we do it, it will get a little better. But the domain, when we did this, what did we have to worry about? Zeros where? In the denominator. We factor the denominator, set it equal to 0, and that is my domain. Because we can't divide by what number? 0. So again, most of this is review, because we did it chapter 1, and we've done it the last 2 days. But I wanted to talk about it again. Okay, I find the domain of the reciprocal function. The reciprocal function is just x over 1, so the reciprocal of that is 1 over x. What's the domain here?
Anything but 0.
So x such that x cannot equal what?
0.
0. And we need to be writing the domain in that set notation. We are going to be, if you notice, like on step 5, does it say intervals? No. Maybe it's 6. 7? Okay.
Perform interval analysis.
Okay. When I should just have me a copy up here, not be.
Vertical asymptotes.
Vertical asymptotes we're going to be doing. Okay, number 7 is interval analysis. So we're going to be reserving that interval notation for my interval analysis. In calculus, we'll do interval analysis with the derivative, the second derivative, and this. So we'll be doing it 3 times. So I don't want to be doing my domain in intervals as well. I want to distinguish it. It's different. There's nothing wrong with interval notation for domain, but we're just going to grow up a little bit more in our math skills. Let me know when you're good, okay? Let me know when you're good. Oh, I'm good. Okay. So, asymptotes. You need to know what an asymptote is. An asymptote is an imaginary line that a curve continually approaches but does not meet at any infinite distance. You should have been introduced to asymptotes in Algebra 2, and it's always the funnest word to say in math because you think you're getting away with something. So an asymptote is an imaginary line that I get closer and closer and closer to, but never get to. There are horizontal asymptotes, there are vertical asymptotes, and there are slant asymptotes. You need to know the difference between them. You can have vertical and horizontal. You can have vertical and slant, but you can never have a horizontal and a slant. And if you look at step 5, it says find horizontal, if any, or slant asymptotes using the rules. And we're going to talk about the rules. But again, you can have a horizontal or you can have a slant, but you may not have both. We will not be doing slant for a couple days, but we're going to focus on horizontal and vertical for a while. If you look at the picture, can you see it tells me that there's a vertical asymptote at x equals 0? For this is the reciprocal function right here. If I were to graph 1 over x, this is what it would look like. Do you see how this graph is going this way?
Mm-hmm.
Like it's coming down, and it's going to keep going down, and over here it's going to keep going up, and it's going to get closer and closer to 0, but it's never going to touch it. Okay? You should have. You should have done that before. And it's what it actually is. It's a limit. It's a limit and that we'll discuss more in calculus as well. That number, the limit of that is 0 because it's approaching 0, but it's not getting there ever. Okay? So it also says there's a horizontal asymptote. I did vertical. I'm sorry. Vertical should have gone this way, yes? That's vertical?
Yeah.
Okay. So vertical, up and down. Horizontal. Do you see the same thing happening to this graph? Okay, when we do these are sketches. They're not exact. The only thing that should be exact are your asymptotes. Everything else is the shape of it. If we were to do plotting exact points, the book says like pick some points, make an XY chart. No. Okay? I have a calculator that can make a table if I need exact points, correct? Or if I need an exact point, I can plug in one value. There's no reason to have to plug in 7, 8, 10 values to this problem. Okay. Questions about an asymptote? Does that make sense what they are? Haven't told you how to find them, but does it make sense what they are?
Yeah.
Okay. So, some different asymptotes. The first graph. This graph is 2x plus 1 over x plus 1. If I graphed it, this is what it would look like. And when we graph them, we will make these dotted lines to represent them. Do you see how that graph is approaching that? Okay.
So your domain is your asymptote?
Well, your domain is based off roughly your vertical asymptote because your domain is your x's. Now, that's the other thing I need to talk about. Horizontal, and I'll discuss it more, but I'm going to come back here so there's less. Horizontal is an end behavior. So that means it is over here and over here. It has nothing to do with it's in the middle. Does that make sense what I'm saying? Okay. Horizontal is as x approaches negative infinity and x approaches positive infinity. It has nothing to do with the middle section of my graph. It's just like when I do end behavior, when you guys tell me it's odd or even, what it's going to look like. Okay, we don't do odd or evens with rational functions. That just doesn't happen. There's some things tweaky things that you would notice after you graph thousands and thousands and thousands of them, but we're not going to address that. But again, horizontal asymptotes only go as x approaches negative infinity and x approaches positive infinity. It doesn't have anything to do with the middle of the graph. Okay? Yes?
It's just like watching teaching.
Oh.
Can I ask Connor Bradley a question?
Yes.
Not in trouble. He'll be back in
Okay.
a second.
So, when I graph this function, do you see that vertical is at at x equals negative 1, and if the horizontal is at 2? Do you see how that is? Okay. So on the next one up here, we have 2 over x minus 1 quantity squared. So that would be x minus 1 times x minus 1. If I multiplied that out, it'd be x minus 2x plus 1, right? So if I were to graph that, I would find a vertical asymptote at x is 1 and a horizontal at y 0 in the graph. Just some different picture types you can get. Okay, the next one I have is 4 over x squared plus 1. Now, this x squared plus 1 Is there anything that's ever going to make it 0? Think about it.
No, wouldn't be able to.
There would be nothing that would make this denominator 0, would it? Because if I plugged in -1, which would be the only one, -1 squared is 1, so I get 2. What do you notice this graph doesn't have that the other two have?
Space.
They don't have vertical asymptotes. Yes?
Yeah.
Okay?
Yeah.
It doesn't have a vertical asymptote because there's nothing that's going to make that denominator 0, is it?
Nope.
Nope. It kind of looks like a parabola, but what happens with my ends? They keep going.
have asymptotes.
And there's a horizontal asymptote that we can see, can't we? But there's no vertical because there's no restrictions in our domain. So what would our domain be here? All real numbers. So this would be x such as an element of all real numbers. What would our domain be here?
It'd be negative, maybe 1. Negative 1. Yeah, negative.
So x cannot equal -1. And that gave me an asymptote, didn't it?
So if they are real numbers, they're not going to have a vertical asymptote?
Yeah, if it's all real numbers, there will be no vertical asymptote. Now, there could be an instance where we reduce something out, and so there's still a restriction on the domain, but there's still no vertical asymptote, and we'll see some of those. But,
Could that happen with the horizontal asymptote?
well, the horizontal asymptote is different. It's a comparison
I
process.
have yet to figure out how to
We'll figure out the horizontal. It's a three-step process.
explain it.
Okay. It's not a 3-step process, it's a 3-step, observation. Okay, so the first step we do, we have a rational function. If we have a rational function and you're asked to, with no common factors, so what is the first thing I have to do?
Find common factors.
You have to simplify.
Yeah.
Okay, so this is actually step 1, isn't it?
Yeah.
Because I have to simplify. Okay, then it says step 2. I changed it because the book doesn't tell you that you have to simplify. It just says no common factors, which implies you did what? Simplify. Okay, so step 2 is to graph the vertical asymptote. And we won't graph all of them. We find some stuff, then graph it, but it's the same thing. Okay, so let's graph the vertical asymptotes at the zeros of d of x. Okay, how do I find zeros? Set it equal to what? 0.
So
And d of x means what?
denominator.
Denominator. So you need to set the denominator equal to 0. Have you been doing that to find the domain?
Yes.
Yes. Okay? The only difference is if it reduced out, it's in my domain, but it's not a vertical asymptote. And we'll see that a couple times. Okay? The next thing is to graph. The graph of f has no or 1 or none. It's important. Horizontal asymptotes. You can have infinitely many vertical asymptotes. Okay? But you can have 1 or none horizontal. I want to clear on this.
Yeah.
Okay, so you have, it's a comparison. You compare the degree of the numerator to the degree of the denominator. And you should do this at the start, like go back to the beginning one before you've reduced. Okay? You can do it in any other point, but it's just easier to do it at the beginning. So the first thing you have to do is write it in order, which is the first thing you should have done in the first place, correct? On your test, the problem where I asked you what the end behavior was, it was out of order. And if you didn't put it in the right order, you told me it was odd, but it was really even. So you've got to put it in order. The first one says you need to have these written down because these are not on your sheet. If you're taking a long time, it is in your book, and you obviously can rewatch the video as well. Okay, so the first one, if the degree of the numerator is less than the denominator, then y equals 0 or the x-axis is the horizontal asymptote. If the degree of the numerator is less than the degree of the denominator, what is my horizontal asymptote? Every single time.
0.
Y equals 0, the x-axis. You're hoping for that every time, right? It'd be easy. And you don't have to write all these words. You could put n of x degree. I don't know. I pretty much kind of shortened it. On the other sheet that you have, you may want to, as we go through tomorrow, write some notes on it, but I would encourage you not to write any notes on it until you've done some stuff so you know what you want to shorthand it as. Okay, the second instance, if the degree of the numerator is equal to the degree of the denominator. So x squared over x squared, right? Oh, do you want an example of A first? You want an example of A? Like x, like 7x cubed, blah, 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 over 9x to the fifth, blah, 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 blah. Is the degree of the numerator less than the degree of the denominator?
Yeah.
Yes. So what is the horizontal asymptote?
0.
Y equals 0. Okay? So now if the degree of the numerator is equal to the degree of the denominator, so 7x cubed, that just means I don't care what everything else is, okay? Over 9x cubed. Are the degrees equal?
Yeah.
Yep. So the horizontal asymptote,
There's 3.
nope,
And 1.
is the ratio of the leading coefficients.
So 7
So y equals 7/9.
without that.
Okay? So if the degree of the numerator is equal to the degree of the denominator, it's the ratio of the leading coefficients. And you hope they reduce nicely. Like 18/9 would have been great, right?
Yes.
Because it would have been 2. And 7/9 is just almost 1, isn't it?
Yeah.
Okay, all you have to do is really easy to graph 7/9 because you write a little line and say 7/9. And then dot, 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 dot. It's not hard. Okay, the last one. If the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. But I want you to say but, right under here. I want you to write a big capital but and leave yourself 2 or 3 lines. We're going to fill that in a couple days. Okay? It's a but if. If the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. But if it's greater than by exactly 1. Okay. So let's see. 7x to the 9th over 7x cubed. So is the degree of the numerator greater than the degree of the denominator?
Yes.
Yes. So there would be none. So this is why horizontal asymptotes are not hard to find. It's just a process. You have to know if the degree is less than the denominator, what is my horizontal asymptote every time?
0.
0. Okay. If the degree of the numerator and the degree of the denominator are equal, what is my horizontal? It's the ratio of the leading coefficients. If the degree of the numerator is greater than the degree of the denominator, there is none, but,
Unless.
Oh,
no, there's not an unless. There's never a horizontal, but there could be a slant if it meets other conditions, which we will worry about later.
If it's greater than exactly 1. I heard you whisper it.
Okay, so today this is what we're working on. We're going to work on domain also. I want you to keep doing domain. Even if it doesn't ask for domain, I want you to keep doing domain today, okay?
So we're not doing all these steps yet.
No, this is what we're doing today.
We're doing the
Vertical,
first
horizontal, domain. Okay, we're not doing all 9 of those steps today. No.
Got it.
Okay, vertical, horizontal, domain. Every single problem. I don't care what it says, just do it. Okay, let me know when I'm good.
I'm good.
I'm good.
Good.
What is the AJ?
Horizontal asymptote. Guess what vertical asymptote is? VA. Every single thing you do, you're going to label it. Every single thing. Because when I go through this, I need to know what is your VA, what is your HA, what is your x-intercept, what is your y-intercept. Got it? So every single thing we do, we're going to. And I think I have 1, 2, and 3. 2 and 3 they don't put in the book. So my 1, 2, 3 are different than their 1, 2, 3. Makes sense? But these are out of the book. Good. So determine the vertical asymptote, horizontal asymptote, and the domain. So the very first thing I need to do with every problem is write down the problem. Yes? Okay, so 5x over x minus 1. What is the next thing I do after I write down the problem?
Simplify it.
Simplify. Before I can simplify, I have to what? Factor, right? Can I factor the numerator?
No.
Can I factor the denominator? Nope. Okay, can I simplify anything? No. So I did step 1 already. And I always just say, from my paper, I literally write simp. And I'll put a check. So I know I did it. What's simp stand for? Simplify. Okay? And then I'll do the x-intercepts and the y-intercepts. And then, I think we should do x-intercepts and y-intercepts. What do you guys think? How do I find x-intercepts?
Set the other one to y. I mean,
Set y to
0. Set y to 0.
Right, so set the whole thing to 0, right? So if I set this whole, so I go x-int, what's x-int stand for?
X-intercept.
X-intercept. If I set this whole thing equal to 0, I would have to multiply over by the denominator, yes? And it would be 0. So basically all I'm doing is setting the numerator equal to 0. So I'm going to show my work. And it doesn't have to be detailed. That's it. Okay, so what's x equal? 0. So my x-intercept is 0, 0. Because an x-intercept's a point on a graph, correct? So I don't put x equals 0, I put what? 0, 0. Okay, so y-intercept. How do I find any y-intercept no matter what the graph is?
Set x to 0.
It's that all the x is equal to 0, right? So this is how I do my work. I go 0 over 0 minus 1. That's my work. Because if I put a 0 in the numerator, 5 times 0 is what? 0. And then 0 minus 1. So I have 0 over negative 1, which is what? 0.
0. That's what I said.
So it is what? 0, 0. Now, if I have, here's a hint. If I have an x-intercept at 0, 0, it better be my y-intercept, correct? Yeah?
No.
So basically your x-intercept and your y-intercept.
Only if it's 0, 0. Because these are functions. So functions mean they pass the vertical line test, yes?
Yeah.
So if it passes the vertical line test, if my x-intercept is 0, my y-intercept has to be 0. If you get them not, then you did something wrong. If I have 0, 0 for a y but not an x, I did something wrong. If I have it for an x and not a y, I did something wrong. If you're thinking as you're doing this process, guys, there's lots of checks and balances so you can find mistakes. Okay, so I have simplified my x-intercept, my y-intercept, and I have the graph. Do I have an x and y-intercept at 0, 0? Yeah. Okay, now I need my vertical asymptote. Okay, how do I find vertical asymptote? Set my what? Denominator equal to 0. So my work would just be x minus 1 equals 0. So x equals 1. Again, that's all the work I need. If you want to show more, if you need to show over the adding the 1 over, you're fine. But I just need to, that's basic work, how I got it, correct? Okay, so then I need to do my horizontal asymptote. How do I do horizontal asymptotes? I compare what two things? The degree of the numerator and the degree of the denominator. Okay? So what is the degree of the numerator? 1. What is the degree of the denominator? 1.
So it'd be 5 over
So
1.
no, it's just a second. So it's 1 equals 1. That's my work. That's y. Okay? And so then it's going to be y over, yes, you were right. 5 over 1, so it's just what? 5. Did I show my comparison right here?
And
Yeah, I'd have a less than, an equal to, a greater. That's going to be my work for that. So it seems like a lot, but did that take me very long to do those things? No. Okay, it's going to take you longer to factor most of them than anything else. Now, I've done all those things. We'll eventually graph them. How I would graph them is I would kind of go 0, 0, there. And then I'd say vertical asymptote at 1. So I would put a imaginary line at 1. And then I have a horizontal asymptote at what? 5. So 2, 4. My 1 didn't show up very well, did it? See that? And then we would go through the other process to get the shape of this graph. But by doing this already, you've got some ideas. Do I have to go through an x-intercept? Yes. Yeah, I have to go through this.
So that's when it
And if
crosses
I
the
know
x-axis.
that my graph is somewhere in this little area, right? So it would have to be here, wouldn't it?
Yeah, it wouldn't really have much of a choice.
It doesn't have any choice because it has to go through that. And if I can't cross asymptotes, it's there, right?
Yeah.
Now I need another chunk. Can it be here? No, because this is a function, correct? So it can't be here because it's a function and it wouldn't pass the vertical line test, would it? So it can't be here.
Oh, yeah, I didn't think about
Yeah?
that.
Can it be over here?
No,
Because there's no what?
horizontal.
There's no x-intercept, is there? If there's not an x-intercept, I can't do this, can I?
There'd be multiple
So it's
x-intercepts.
And I don't have any more x-intercepts, do I?
There's only one.
So my only other choice is where?
So yeah, you could just
Right there.
You could just logically.
You can figure this out, but we have other steps that tells us exactly and to check our work. Because if I said my horizontal asymptote, my vertical was 1 and it was really -1, would that change what this graph would look like?
A lot.
Yes. So there are multiple checks and balances in this process. Follow your math and check as you go. If it doesn't work out, go back and check. It's simple. It's just solving basic equations, correct? Okay, what's the last thing we need to do?
Find the domain.
Find the domain. Now again, if you want to find the domain right after you simplify, that's great.
That's what I did.
Okay.
Just so I didn't.
So my domain is x such that,
equal 1.
and how do you know it can't equal 1?
Because you said it equals to 0.
I set the bottom equal to 0.
Like we did earlier with the VA.
Right. So have you really been set up to do all this stuff already, right?
Yeah, this part of it.
Next part of it too. So this is all you're doing today. I would suggest no matter what your problem says, that you would just do these all on your problems today. That would be my suggestion.
So it's just the asymptotes, the domains, and the intercepts.
Yep, intercepts, asymptotes, domains. Every problem because it would, and so, yes, you have to simplify. Okay, so determine the vertical, horizontal, and the domain again. Okay, so write the problem always. Now when I do these problems, guys, I use sometimes can get 3 on a paper, sometimes 2 depending. I do my work on the left and I graph on the right. And it just kind of, no, tomorrow we'll start graphing.
Because this is graphic equation.
Well, that's because that's the ultimate goal. Like
So for
that's,
these problems, we're just doing this.
yes. Today, this is what you're doing. Okay, so 4x over x squared minus 1. First thing I do is what?
Make sure you can
Factor.
Factor. Okay. So I have 4x on the numerator. What did I have in the denominator?
X
You can
one
simplify
minus
x minus
1.
1.
X plus
What, Shelby, did you say?
I said that you could simplify the denominator. That's it.
Okay. So I can't simplify, but can I factor?
Yeah.
Yes. And I have to factor. So it's not a waste. Some people go, well, I just wasted my time. I can't simplify it. No, it's not, because I have to set the denominator equal to 0 anyway to find the vertical asymptotes in the domain, correct?
Okay.
So if I have to do it anyway, why not do it at the beginning? You want to do our domain right now so we don't forget?
That's what I'm doing right
Okay.
X plus or minus 1.
So my domain, setting that denominator equal to 0, is x such that x cannot equal
now.
Plus or minus 1.
plus or minus 1. Now, you guys never thought you'd be able to do domain that quick, did you? Why is it not? Why can't I have 1 and negative 1? Why?
Because it can equal zero.
What equals 0?
The numerator, the denominator.
Dominator.
Denominator. Okay, so now I'm there. So what's next?
VA.
X-intercepts, thank you. How do I find x-intercepts?
So the whole thing equals.
Yeah, but
The
basically
numerator.
just the what?
You're saying why does
The
The numerator.
Oh, the numerator is 0.
Okay, so 4x, oops, those should be dots, not equals. Equals 0, so it's what? 0, 0. Then next,
Put y intercept.
y-intercept.
Put a 0 in.
Plug the 0 in for x's. So that gives me 0 over 0 minus 1,
0,
0, 0. Tell me to slow down, because I think the people helping me aren't writing.
Alright, because
Okay, no, but you can talk it faster than they can write. We're not going too fast for everybody? We
I'm
good?
good. I'm right where I need
A
to
little
be.
bit.
Okay, so say something, Gentry. Do you get where we're at?
Yeah.
Okay. So now what, Gentry?
You have to find the VA,
The VA, what is VA?
the vertical
And how do I find vertical asymptotes, Gentry?
Um,
Jeffrey?
I don't know how. I know HA.
No, go up one more on your list. It's there. No, under what you wrote down. It's the step 1 on what they wrote or step 2. Step 2 on there.
The degree of the numerator.
That's horizontal. Go up one on your list.
On here?
No, on your list that you wrote in your.
I didn't find it. It's like 1, 2, and then 2.
Oh, you only wrote those.
Yeah.
Okay. So you better write it down now. Okay, the vertical asymptote, what did I said equal to 0?
The
Denominator.
It's
So I
basically-
have x minus 1, x plus 1 equals 0.
So it'd be 2.
Yes, okay, it's basically my domain, but if I've reduced anything out, it would be in my domain, it would not be in my vertical asymptotes. Okay, so it's roughly
Oh, so the VA is the
the
reduced. only.
reduced,
Okay, I'm
yes.
putting that big.
The VA is that's why we reduce very first thing. Okay, our VA is a reduced. So now, what are my vertical asymptotes?
Negative 1 and positive.
Plus or minus 1.
Now you
Then now we have our
got
HA, which is what?
horizontal.
Horizontal asymptotes. And horizontal asymptotes are degree, yes? What is the degree of the numerator? 1. What is the degree of the denominator?
2.
2. So 1 is what, 2?
Less than.
Less than 2. So-
it'd be
It's a 0.
So y equals 0.
0.
Because your rules tell you if the degree of the numerator is less than the degree of the denominator. So that's why I always write this. 1 is the degree of the numerator, 2 is the degree of the denominator, and then I put my inequality in the middle.
Wait, why is it 0?
Because your first rule tells you if the degree of the numerator is less than the degree of the denominator, it's y equals 0. Every time. So now at this point in our work, we would start putting some stuff on the graph. So let's put it on there. X-intercept is 0, 0. Do I have an x-intercept is 0, 0 on this graph?
Yeah.
Yep. And then y-intercept vertical asymptote at 1 and negative 1. Okay. And then horizontal at 0. And what I do on that is I just kind of put slant. Now, this picture has a middle piece and 2 side pieces.
Because the middle one's a slant one.
Well, the middle one it doesn't have a slant. There's no, because the slant actually has a slant. You would see it. You can't have a horizontal and a slant at the same time. You have a horizontal or you have a slant. Because horizontal, remember, only affects out here and out here. Nothing in the middle. Okay? But do you see how I'm getting closer? I would say asymptotes are like magnets. They draw the graph closer. Down here, it's getting closer to this asymptote, and what's it doing up there? Getting the same thing. Okay? When you hit an asymptote, you go to positive and negative infinity, one of those two. Okay, x-intercept, y-intercept domain. This is our last one. I don't think your directions will say it today, but I would encourage you to do it. It's not hard. Okay, first step, write it down. So 5x squared over x squared minus 1.
Can you take a
Then I have to do what?
factor?
Factor. So I have 5x squared over what?
Next
X
square
squared.
minus.
Oops. Nope.
X plus,
Oh, x
X
plus
minus 1 or
and 1.
plus
Yeah, I was going with you guys and you were wrong.
What the?
I already have the equation. Okay, step 1 done. Now hopefully some of yours reduced today. If I had something that reduced, okay guys, do your domain before you reduce. Got it?
And do your VA
Your
after.
domain is the only thing that goes off of the non-reduced.
Reducing when you take something out of there. and
Right.
put it
So if I had x minus 1 in the numerator and denominator, I would use that plus 1 for my domain, but I would get rid of it elsewhere.
For the VA.
Yep, for the VA. Because think about it, guys. I found the vertical asymptote by setting the denominator equal to 0, yes?
Yes.
I find the x-intercept by setting the numerator equal to 0, okay? And an asymptote I can never cross and never touch, yes? So can something be a vertical asymptote and an x-intercept?
Nope. it's
No.
gonna be crossing and touching it.
Yeah, so that's why we have to get rid of those. Okay, so x-intercept, right? Labeling my work.
Are we doing domain before
Oh, yes, domain.
Oh, how?
x such that x cannot equal
Plus
positive
or
or
minus
negative
1.
Good job. I always do domain last, and I don't know why, because then I forget it half the time.
I feel like it just goes in order.
It does, because you don't want to reduce before you do your domain, because then you may forget it. So I should rewrite that sheet. Put your domain, like, under that sheet that I gave you, write domain right under simplify. So like, put an arrow and put it right under simplify. Okay? And you guys, and I need to retype that.
Yeah.
Okay, so x-intercepts, I set what equal to 0?
Your
Your numerator.
Numerator. Okay, so 5x squared equals 0.
0.
It's 0, but what kind of a 0?
Double 0.
It's a double 0. So what's going to happen to this?
Bounce.
It's going to bounce. And I put a times 2, so I remember when I graph that, it's going to do what on there? Bounce. Okay, Y-intercept. How do I find Y-intercepts? Any graph, no matter what I give it to you, what do we do?
Put zeros in for x.
0 and for x. So I just keep getting the same thing over and over. You won't though. And I did it on the original, and that's okay. You can do it on the reduced as well. It doesn't matter. It should come out the same. Ryan, can you slide that line on? Okay, so it's what?
0,
0,
0.
0. And I knew it should come out to be 0, 0 because I have the x, right?
Right.
Okay. So now what?
Vertical
Vertical
asymptote.
asymptote. How do I find vertical asymptotes?
Your denominator.
My denominator, and I use the factor because that's what I'd have to do anyway, right?
So it's x equals plus
Plus or minus 1. Oh, that should be 0 right here, shouldn't it? Okay, then what?
The horizontal position.
Horizontal. How do I find horizontal?
Compare the
Yeah.
numerator, the
Okay,
powers of
three.
the numerator.
So I have 2 and 2, so they are equal.
of y equals
It's
0.
5.
So y equals 5 over 1. Yes?
It is 5.
5 and 1.
And 5.
So it's 5.
Yeah.
So let's see what this would look like. See if we can tell what it's going to look like.
It's gonna be weird.
Okay, there's my x and y axis, right? Okay, I know that I'm going to go through 0, 0. I got 1 and negative 1. Yes?
Yeah.
And I've got 5. And you got, I just put a 5 there. Okay?
So
Now remember, and this is something that I do, I don't put my horizontal in the middle here because is it going to affect the middle here?
Yeah.
No, it's only going to affect where?
And behavior.
And behavior. So I don't need it there because it will mess my brain up. So is this graph going to be in this region down here?
Yeah.
What's missing? I don't have an x-intercept, so can it be over here?
No.
No, so it can't be here, it has to be where?
Up there.
Up there. Can it be over here?
No.
No, because there's no x-intercept. So it's gonna be where?
Over there.
Over there. Now, we don't know, it could go like this,
Mm-hmm.
or it could go like what?
I know what.
That. So we'll have to do an interval analysis for that to figure that out. That's why there's sometimes we have other things we have to go along with it. So today, no matter what, you're gonna do what things?
X-intercept.
X-intercept, Y-intercept, vertical asymptote, horizontal
Domain.
domain. The nuts and bolts today. Got it? Guys,